Hi future doctors, welcome to the next class. In this class we'll see relative density or specific gravity of the object. So relative density, how it is going to be defined. So relative density is equal to density of the body by density of water at 4 degrees Celsius. This one only they will represent in terms of weight of the object in air by loss of weight of the object in water, that is nothing but W1 minus W2. So W1 is the weight of the object in air. W2 is the weight of the object in water. So W1 minus W2 is loss of weight of the object in water. This is going to be relative density. So how it is going to be helpful for us in solving problems? So they will give relative density of the object is 1.2. Now what is the density of the body? Relative density of that body is 1.2. Then at the time what is the density of the body means? So 1.2 is equal to density of body by density of water at 4 degrees Celsius is 1000 kg per meter cube. So they will say 1 gram per cc in grams. So if you convert this into kg per meter cube, 1 gram is 10 power minus 3 kg. 1 centimeter cube is 10 power minus 2 meters whole cube. So if we send this one to numerator, 10 power minus 6 meter cube. 10 power 6 minus 3. So kg per meter cube. 6 minus 3 means 10 cube. That is only 1000. The density of the body is 1.2 into 1000. So 12 into 100. So 1200 kg per meter cube. This is the density of the body if they have given relative density is 1.2. So indirectly they are giving density of the body for us by giving relative density. You should not forget that. Next, sometimes they will give weight of the object in water, weight of the object in air. At that time also, you can calculate relative density at the same time density of the body. So let us assume in air, weight of the object is 15 newtons. So in water, weight of the object is 48 newtons. Then relative density of the body. So relative density is 50 by 50 minus 48, that is going to be, so 25 you are going to get, isn't it? Like this they are going to give for you people. At that time again you can calculate density of the body by so density of water. So in so many ways you can get like this. Next, relative density of the liquid they will ask. Relative density of the liquid means relative density of the body means density of body by density of water. Relative density of the liquid, density of liquid by density of water. At that time, what you should calculate one extra physical quantity means so weight of the object in that liquid. So that is going to be given like this: W1 minus W3 by W1 minus W2. So what is W2? We said weight of the object in water. W1 weight of the object in air. Now W3 is weight of the object in that liquid. This is going to give density of liquid. This is the relative density formula. So again, density of liquid by density of water is 1000 kg per meter cube. So these densities are going to play a main role whether to object to flow, object to sink, whether object partially submerged. For all these cases, this density is going to play main role. So did you observe if you have seen any dog or pig? So it is going to be whenever it is going to be floating on the liquid after dying. So partially it is going to be immersed. Like that, if anyone jumped into the river, so after dying 2 to 3 days, body will be floating. Initially it will not float because later densities are going to be changed. So how to take that densities into consideration to flow or to submerge or completely immersed in a liquid? We will see now. Just see if object is placed in a liquid. If object is placed in a liquid, so density of the liquid is dl, density of the body dB. it is immersed completely, it came to bottom of the vessel. Next, another one, density of the liquid. So another object we have taken, this is going to be density of the body. Next, another case, liquid up to here we have taken, density of the liquid. Now object is placed like this. This is density of the body. So it mixed completely and it went into the bottom of the vessel. So it completely immersed, but it is on top. This is partially immersed. So for all these cases, how the densities are going to be taken? So density of the body is greater than density of the liquid. So what is going to happen means weight is going to act downwards. Buoyancy force is going to act upwards. Here which is bigger, which is higher? Weight is more than buoyancy force whenever density of the body is greater than density of the liquid. So in this case, density of the body is equal to density of the liquid. Here mg is greater than fb. Here mg is equal to buoyancy force exactly. So what is fb buoyancy force formula? dl vg. So mg db vg, mass of the body db vg we wrote. So if you cancel, db equal to dl. Now in this case, density of the body is less than density of the liquid. So to float object by partially immersed means this is the condition. Density of the body should be less than density of the liquid, and at the time it will not sink. It will be floating or it will be there by partially immersed. How much will be inside the liquid? How much will be inside the liquid means, let us assume this is the volume, portion of volume inside. Then this is going to be remaining outside. Total volume is going to be V. Now how we will write formula? So at this case, for immersed portion, weight or buoyancy force, FB is going to be equal to dl V in G. This should be equal to weight of the liquid displaced. That is only going to be mg. That one we will write dBVG according to Archimedes principle. So now Gg if you cancel, then V in by V is equal to dB by dl. So what is this V in by V means? Fraction of volume inside the liquid. So they will give an object is placed inside water. What is the fraction of volume inside? At the time they may give density of body or density of water is 1000 we will take. Let us assume simply we will do one problem. So previous one only, it is easy for us. Relative density of the object is 1.2. Let us assume relative density of the object is 1.2 or 0.9 you can take, or 0.8. Relative density of the object is 0.8. Then find the percentage of fraction of volume inside the liquid. Percentage whenever they are asking, V in by V is equal to dB by dW, because liquid there water. So water is liquid, but every liquid may not be water. You should remember that. Here they mention the object is placed inside the water. Relative density of that object they give. Density of body by density of water. So how much they give? 0.8. 0.8 into 100. That is going to be, so 80% is going to be inside, fraction of volume inside, percentage of volume inside. So simply relative density is equal to fraction of volume inside. Now what is the fraction of volume outside? Fraction of volume outside means, so this is V in. From this, V in is equal to dB by dl V. Fraction of volume outside means V minus V in. How much volume? Total volume minus how much volume inside. So what is volume? V. V in, again we will write dB by dl into V. So finally 1 minus dB by dl into, that is fraction of volume outside. So if you calculate inside, what is the fraction of volume outside? So directly we can write, but we are writing according to formula. 1 minus dB by d, density of water, into 100. V out by V. V out by V, this is fraction of volume outside means. So V in by V is fraction of volume inside. V out by V is fraction of volume outside. So 1 minus dB by dW. dB by dW is nothing but 0.8. So 1 minus 0.8 is nothing but 0.2. 0.2 into 100 is nothing but 20%. By seeing this also, we can say 80% is inside means 20% will be outside. Therefore, if you know inside, you will get outside without doing anything, isn't it? So this is very important model, important formula. How much fraction of volume inside the body? On this, they will ask so many problems also. How much going to be inside the liquid? At that time, base area is going to be same. We can calculate this by replacing V in. So volume inside is going to be area into length. So if X part is going to be immersed, then remaining is L minus X, isn't it? So that V in we will write here area into X or L, small l we will write. So like this we can solve the problems. This is about laws of flotation. So in this they will ask problem mainly on this area.